there.
I'm done.
Holy, everybody's going to think it's a record because I just started recording and you're like, pow, I've learned how to take notes with longer hands. Everybody else got this, I assume? Cool, 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 cool. Really, these are the diagram, you know, you can look at, but this is what you need, just the equation. And if you want, you can write down this, you simply add up the resistances. Like voltage in series, you add them up. But resistance in parallel is weird. And exciting.
I'm done if you're waiting for me.
I always am, thank you.
Hold on, I want to write down or copy this diagram. So
okay, sure.
Can you go?
Yep. For those of you who might want to just know where the diagram is, it is page 527. If you'd prefer to kind of make a note to refer to it, it's figure 1, page 527. Another week of remote learning. So that means that, what did I say? That means today's Thursday, so the test, I said the test would be next Thursday, is that correct?
Yep.
Okay.
I'm done now.
Thank you. Anybody else still writing or anything, copying? All right, here's the next one. That little diagram's on page 528, figure 2. And then once, Nathan, can you let me know when you're done copying it down, then I'll say more.
I'm done.
Thank you. Had a whole bunch of thoughts. I need to make notes for myself. Unrelated, does anybody on staff have anything like a mullet? Do you guys ever notice? No, nobody?
Wait, what was the question?
Does anybody on staff have anything like a mullet? Like, do you ever look at any particular teacher and go, oh, it kind of looks like a mullet? Their hair. No? Okay, I need it for a joke. Okay, don't worry about it. All right, so look at this equation. Now here, I'll tell you what my common mistake is so that hopefully you don't make it. So it's 1 over R parallel equals 1 over R1 plus 1 over R2 and so on and so forth. What I tend to do is I do these, sometimes they're nice fractions they work out, sometimes it's decimals, whatever. and I figure out what that number is, let's just say it's 1/3 plus 1/, no, that's a bad example. 1/5 plus 1/5 plus 1/5 is 3/5. 3/5 is 0.6. And often my brain just skips a beat and it goes, okay, R parallel equals 0.6. That's not true because you need the reciprocal, right? So if it's 3/5, if that's the answer, that means that R parallel is 5/3. And you'll see it when we get to examples. I just want to note that so that you don't kind of make that mistake that I too often do. Remembering the rules for adding fractions. And then here's the last little bit of notes that you got to do. Draw these out.
If you're still waiting for me, I am done.
Thank you. Anybody else need more time? All right, so let's get down to Ben S. Okay, so practice number 1 from page 530. Part A, we're given this, and it says, what is the total resistance of the mixed circuit? So right here, this will be kind of where we have our total, will be right here. Note that each resistor has a resistance of 5 ohms. So they're all 5, which makes it a little bit easier. So if this wasn't parallel right here, let's say this was just another resistor, it'd be 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. Our total is 20. But we have to deal with this nonsense first. So R parallel, oops, see, I already 1 over R parallel equals 1 over R2 plus 1 over R3. So this is 1 over 5 plus 1 over 5, oops, which equals 2 over 5. Now remember, it's 1 over R parallel. It's incredible how often I would just stop. Okay, 2 over 5, we're done. It's 1 over. So 1 over RP equals 2 over 5. Cross multiply, or you just flip, excuse me, both sides. RP over 1 equals 5 over 2, which would be 2.4 ohms. Not the best ohm symbol, but. I can go back if you need me to.
How come you flip the fraction?
Why did I?
Yeah.
Okay, let's look at it this way. Let me move my camera. If I just go in a different color, 1 over RP equals 2 over 5. If we want to solve, let's say this is just X, 1 over X. We want to isolate this, multiply both sides by X. I'll do the very kind of long version. So it'll be 1 equals 2 RP over 5. We want to get RP by itself. Multiply both sides by 5. 5 equals 2 RP, and then divide both sides by 2, becomes 5 over 2 equals RP.
Okay.
Is that okay? We're just,
Yeah.
I'm flipping it. I'm just kind of giving you the shortcut, but we're isolating it.
Okay.
Okay.
So
So
wouldn't that be 2.5?
I was thinking of 2 over 5 as where the 0.4 comes from. Yes, thank you. 2.5. Merci. So this parallel portion is 2.5. So 5 plus 2.5 plus 5 plus 5 RT. I gotta be careful and make sure I'm showing this all the time. 17.5. 17.5 ohms with sig figs. Is this a 2 sig fig? Yeah, equals 18 ohms.
Could I just have a minute to like look at it? I was just trying to take down the diagram.
Totally. Yep. I was just saying I'm moving this all around. So if you need me to move it somewhere, just say so. Just let me know when you're done, please.
So the idea is to figure out the parallel resistors and then just figure out the series and add it.
Yes.
Right.
Once you've figured out what it is in parallel, you can treat it as if it's in series.
Okay.
Can you guys see when I get these text messages from staff? Does that pop up on your screen?
No.
That's probably good.
We can hear the alert, but we can't
Okay.
see what they are.
I should probably mute that anyway, just so it's not bothersome. Okay, any questions about this or anything, any parts of the page you need to see? Ada, you good?
Can I just have one more minute?
Yeah, man. I just didn't know. I'm not trying to rush you.
Okay, I think I'm good.
Cool. All right, let's do part B. Do you want another example? Probably, hey?
Sure.
If you don't, I don't need to do it, but if people want it. So it looks like this. There's my unreasonably hand-drawn facsimile. You wouldn't imagine how fun these are to draw decently for tests. Believe me, super fun. Oops, what am I doing? That's getting confusing. It says 1, 2, 3, 4, 5. Same idea, each one is worth 5 ohms. So we got to deal with this nonsense first, and then we just add it to 5. So what that means is, oh, there I go again, 1 over RP equals 1 over 5 plus, because we have 4 of them, 1 over 5 plus 1 over 5 plus 1 over 5. So this equals 4 over 5. 1 over RP equals 4 over 5. Therefore, RP equals 5 over 4, which equals 1.25. Did I do that one right for a change? Yes. Our total equals 5 plus this right here is 1.25, which is 6.25 with sig figs, 6.3 ohms. How's that? Any questions? Any problems, comments?
I'm just not quite done copying it down.
That's okay. Just let me know when you is, please.
Wait, why is it 6.3, not 6.25? Oh, never mind. Never mind.
Just sig figs. I'm going to answer it anyway, just in case anybody else is wondering. It's just sig figs.
I just wrote down 6.23 and then I'm like, what did I do?
Oh.
Yeah, we're good.
Is that embarrassing, like, to make mistakes? Because I don't know what that's like.
Yeah.
It's just gold that flows out of the end of this pen. Anyways, are you good, Ada?
Yeah, we're good.
Anybody else? Because here's where it gets interesting. So let's look at, I'm going to do the practice on page 532. So practice 1, page 532. And it says repeat sample problem 1. Well, sample problem 1 looks like this. I'm going to draw it big and you'll see why in a moment. I'm drawing it big because now for each spot along here, we need to figure out resistance and amps and volts. Oh man, I gotta make sure I stay on the screen. So at every point, including this, so the total, the R1, R2, and R3, including like V1 and I1, I2 and V2 and blah, blah, blah. We're figuring out all of them. Something on my screen just popped up and said my internet connection is unstable. So at any point you want me to repeat anything or slow down or whatever, please, please, please say so. Try and keep an eye on the chat part too. Okay, so this is 1. I'm just going to put it small so I don't take up space. 2, 3, and then this is the so this is our total. But as far as amps and volts are called, this would be the source. So anyways, what do we know about this with the following values? So V source equals 40. So here V equals 40. R1 equals 25. So here R equals 25. R2 is 30. And R3 is 30. Now, something that will help us here, and I'll just write it in the middle, is R equals V over I. And I'm mentioning that because once we have 2 of these, at any one point, we can figure out the other one. And we have to remember our rules for volts and for amps, and you will get those equations. You'll be writing the test from home. So anyway, I'll try and let you guys lead me a little bit here. Where do we start? What can we possibly do with the information we're given?
Find the total resistance.
Find the total resistance, because that's the one kind of gap or hole that we can plug right now. Once we have our total, what will be our next step?
Then we can use the V and R to find I.
Yes. And so once we have I, well, actually, I'll stop there. Okay, hang on. There's a question or a chat. I just want to make sure I understand. Is resistance at the source 0? No. Oh, like at this particular point? Yes, it would be. We're just, Kate asked, is the, like at this point, is it 0? Yes. There's no resistance as the current goes past this point. We're just kind of putting it here to figure out what the total is. That's a good question. I've never had that before. Okay, so we got to get the total. First thing we got to do is got to get the parallel parts here. So maybe what I'll do, if this helps, is maybe I'll try and see if I can remember to do it, is I'll do each one in a different color just to help clarify things a little bit. Okay, so R parallel, let's do that first. So R 1 over RP. I'm going to sneeze soon, and that means it's probably going to be loud. Excuse me. 1 over, this is R2 plus 1 over R3. My camera. So 1 over RP equals 1 over 30 plus 1 over 30, which equals 2 over 30, which equals 1 over 15. Therefore, RP equals 15 ohms. That's pretty ugly ohms, but it's what it is. So I'll just put it in here in blue. I'll move the screen a second. RP equals 15. And now that we have that, I don't know which part of the screen to show. Now that we have that, 15 plus 25 is 40. So RT equals 40. Any problems thus far? Everybody's good?
Yep.
So now, as whoever it was pointed out, the amps here, I at the source, we just use this. If V is 40 and R is 40, 40 divided by 40 is 1. So it's 1 amp. So now what do we do?
Wait, is it off the screen? I can't see.
What are you looking for? I'm showing just the circuit.
You plug it into the equation.
Where plug what in where for what?
R equals VI.
Like to get I?
Yeah.
Yeah, we did. We have that.
Oh, okay. I wasn't paying attention. Sorry.
Way to go. You said you weren't paying attention. You could have just said, sorry, my internet cut out, instead of you checked Snapchat or something. Oh, hang on. Got a question on the chat. Is resistance, okay, does the current at R2 and R3 split in half? Not always. It's not always that these two are equal as far as kind of volts and amps and stuff. Sometimes it is, but it's not a default. So what can we do from here? We have amps at the source are equal to 1. Do you guys remember the relationship, how the amps go through this bad boy?
You add up the series and, oh no, you add up the parallel and the series are equal.
The series are equal, which means this right here, I equals
1.
yep. I'll put 1 point I. I don't like doing my I's like this, but when I equals 1, it's confusing. Yeah. So now that we have this, we can use this to get our volts. 25 times 1. Give me a second. Let me punch that into my calculator. It's 25. Are we okay with this?
Yeah. So we're just trying to solve for all the missing values. So like the current resistance and volts at every point on this thing.
You got it, sister.
Okay.
Yep. Yep. So we've got all three here. We've got all three here. Now we need to get these two. Now, as this turns out, like Kate had asked, are they always the same? It's a bit of a hint. R equals 30 for both of them. So it's a very good chance that the I and the V will be equal as well, because it'll be proportional. And if you look at it this way, two different ways to look at this. I, the amps here, equals 1. This, when they add up, the amps will need to be 1. So it's possible that they're both 0.5. With, this is the easier one, with volts, it's 40 here, 25 here. That means this must be 15, and volts are equal. And if they're equal, then these both have to be 15. So this 15 plus 25 is 40.
So if they had different resistances, then the current would be different.
Yeah. And if they had different, then you would have been given a bit more information, because as it is right now, if it was RS30 and then RS10 or something, it would be a lot trickier. You would be given one more bit of information for one of them, I or V. So you can figure it out one way or the other. If you're given V for this, you know it's equal. If you're given I for this, this one plus this one has to equal this one for I. Oh, my hand. That's apparently normal. Did I interrupt you? Are you okay with that, Nathan?
Yeah, that's good.
So then I equals what, my friends?
0.5.
Yeah, man. 0.5. You got it, Park Pontiac. And then when you would write them out, these are 3 sig figs. So you would write 3 sig figs for each of these with the units. On the test, when I give it to you, because people will approach this differently, they'll do their scratch work differently. At the bottom of the page, I'll be like V1 equals blah, V2 equals blah, and then you would write it out there. It makes it easier for me, especially so I don't have to chase things around. And just make sure your final answer has units. Oh, this green marker smells. Make sure your final answer has units and sig figs. How is that? We can do another one, a crazier one if you like, or we can end it there and let you go. Totally up to you. I get paid the same either way.
I think I'm good personally.
Yep, I don't mind doing another one. But if you're good, you can bounce your way out, or you can hang around, whatever you want. If anybody wants me to do
What
another.
what would the difference be with the crazy one? Is it like different resistances or something like that?
It'll be the parallel is kind of a combination. Like this is the kind of the crazier one. So you have to kind of, it's a little bit harder because it's a little bit more complicated, but all the same rules apply. You still do everything the same. The kind of trickiest part, if you will, here is making sure that you treat these two, R2 and R3. These guys are in series. They are in parallel with R4. So it's just kind of navigating that. Got a question from Kate.
Okay.
Can you explain all the terms in number 3, page 530? Number 3, prove that the equivalent resistance of 2 identical resistors in parallel is equal to half the resistance of one of the resistors. does it explain the terms? Can you explain all of the terms? Okay, so here's the question she's asking. Oopsie. Stay. Prove the equivalent resistance of two identical resistors. So each of these like squiggly lines, that's a resistor. It's a place that the current goes through and the resistor slows it down. Prove that the equivalent resistance of two identical resistors in parallel. So imagine there was just for this has nothing, this one here has nothing to do with the question, but just imagine there's just one resistor. Prove that the equivalent resistance of two identical resistors in parallel is equal to half the resistance of one of the resistors. All you need to do for that is losing people. All you need to do for that is kind of make up numbers. It's kind of like anytime you get one of these, like what happens when the initial velocity is halved? Well, then it shows how it changes acceleration and blah, 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 blah. So you pick numbers. You pick whatever numbers you want, plug them in, and then take the half of one and show what it does to change it. Does that make sense, Kate? You okay with that? I know that's
what would the equivalent resistance be?
That the equivalent resistance. So two identical resistors, whatever it is that they equal to, is equal to half the resistance of one of them on their own. So here, let me try it this way. Nope, that's got writing on it. I don't need to be that far away. Come on. I have so much crap on my desk. Try and set things down, things fall over because there's not a flat surface. Okay, so let's say in parallel. So let's say we have goes like this. And then we've got, wow, this is really terrible drawing. Two identical, so let's say each of these is worth 5. The equivalent resistance of the two. So first you figure out what is the resistance in this circuit right here. So it's 1/5 plus 1/5, that's 2/5, you flip it over, that's 2.5. So the R total right here equals 2.5. Now it says prove that the equivalent resistance, 2.5, of two identical resistors in parallel is equal to half the resistance of one. 2.5 is half of one of these. I kind of did the question for you. Do it with some different numbers. Do it with 7.6, something weird, and you'll see it'll still work out. Does that make sense? I ended up just doing the question. And the same.
Yeah, that makes sense.
Are you good? And then Kate says the same for number 4. It says, recall that all loads have electrical resistance. Suppose that you connect a number of loads in your home in parallel. What will happen to the amount of electric current with each load that you add? Would you be concerned about this? So in other words, every kind of light bulb and everything, as the current goes through, it slows down. That's what it's asking. It's just kind of a, oh, she says, please and thank you. So would you be concerned about this? If, like, what does that do to the rest of the series in your house? It's something, I don't want to answer it again by giving it away, but just draw out just with a couple of loads. Notice now that we're talking about resistors, everything is drawn like a resistor. Before we got talking about resistors, things looked like a kind of a, I don't even remember how they were drawn. They kind of looked like little light bulbs or something. Yes, Kate, yes. Loads are just things that require electricity or require part of the energy. Yeah, yeah. Anybody else? We're good. If you have, yeah, you're welcome. If you have questions about any of these, we don't have the test till Thursday. Tuesday, you do need to show up for attendance. That'd be a good time to ask questions and stuff like that. That's all I got for you. Oh, wait, another chat. Welcome. No other questions? All right, my friends.